Hi there, I'm Silvia Montagnani. I'm a PhD student in co-tutel between the University of Lille and the University of Frankfurt, respectively for physics and economics. My PhD subject is on climate and financial tipping points. For this poster, I'm presenting a work in collaboration with a group of physicists from the institute called the AICC-Action in Paris. We started from a question that was, is a financial system based on debt long-term sustainable? So we started from a model that they developed to estimate the trade-off in between growth and risk in bacterial colonies. And we decided to extend it to account also for debt. This is because it's easy to draw parallelisms in between biological system and the financial system. So, for example, as you can see, you can draw a parallelism in between environmental uncertainty and investment risk, and also a parallelism in between survival probability and the bankruptcy risk. But then we were asking ourselves, where is debt? Is there a parallelism for a biological system that has similar dynamics as debt? And why, if there isn't, this mechanism is not there? So we extended the Kelly's model, which is a gambling model based on information theory, to account also for debt. And you can think about it as a biased random walk with the possibility of resetting. One of the main results that we have found is that debt-dependent growth is a threat to the financial system itself. So growth is can be seen as a financial risk. Why? As you can see from this graph in the back, debt enables early exponential growth, but at the same time, payback can induce collapse if earnings fall short. And this is what you see here. So it's not long-term sustainable. There is a trade-off. And also in the rest of the working paper, we also evaluated the phase diagram where is optimal to have debt and where is not. But generally, on a long-term basis, is not sustainable. Not only, one other important additional result is that survival probability is non-monatomic with payback time. So what does it mean? That when you pay back the debt, actually, you don't erase the risk. So you don't erase the risk of bankruptcy or the risk of mortality for biological systems. This is what you see here. This is because of an effect in stochastic environments called hysteresis. So it's asymmetric, the recovery of debt and capital. To conclude and to sum up, this analysis underscores the necessity to shift from a paradigm that just maximizes growth to a paradigm that actually maximizes persistence, as in biological systems. On a last note, to conclude, and to also underscore the reason why we pursued this study, is because, and to connect it with the aim of this conference, one of the main factors that actually impedes climate action and the energy transition is that debt takes energy from the future and is a claim on future energy that allows this energy to come in the present. But actually, this mechanism doesn't take into account laws of thermodynamics and precisely energy dissipation. So basically, this decouplement between the economy and the biophysical reality is one of the most dangerous mechanisms in terms of our socioeconomic system. And this is why we did this study as well. Thanks for listening.